Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 1, Topic, The Phases of Compiler. Phase of compiler, lexical analysis. It contains a sequence of characters called tokens. Input is source program and the output is token. Syntax analysis. Input is token and the output is parse-tree. Semantic analysis. Input is parse-tree and the output is expanded version of parse-tree. Intermediate code generation. Here all the errors are checked and it produces an intermediate code. Code optimization. The intermediate code is optimized here to get the target program. Code generation. This is the final step and here the target code is generated. Here the diagram shows the 6 phases of a compiler. One by one, here we are going to see the phases of compiler. First one is lexical analysis. In a compiler, linear analysis is called lexical analysis or scanning. For example, in lexical analysis, the characters in the assignment statement position equal to initial plus rate into 60 would be grouped into the following tokens. The identifier position, the assignment symbol equal, the identifier initial, the plus sign, the identifier rate, the multiplication sign, the number 60. Next one is syntax analysis. The second phase of the compiler is syntax analysis or parsing. The parser uses the first components of the tokens produced by the lexical analyzer to create a tree-like intermediate representation that depicts the grammatical structure of the token stream. A typical representation is a syntax tree in which each interior node represents an operation and the children of the node represent the arguments of the operation. The next one is semantic analysis. The semantic analysis checks the source program for semantic errors and gathers type information for the subsequent code generation phase. It uses the hierarchical structure determined by the syntax analysis phase to identify the operators and operands of expressions and statements. Next one is intermediate code generator. After syntax and semantic analysis, some compilers generate an explicit intermediate representation of the source program. This intermediate representation can have a variety of forms. In 3-address code, the source program might look like this. temp1 equal to integer to real of 60, temp2 equal to id3 plus into temp1, temp3 equal to id2 plus temp2, id1 equal to temp3. The next one is code optimization. The code optimization phase attempts to improve the intermediate code so that faster running machine codes will result. Some optimizations are trivial. There is a great variation in the amount of code optimization different compilers perform. In those that do the most called optimizing compilers, a significant fraction of the time of the compiler is spent on this phase. temp1 equal to id3 into 60, id1 equal to id2 plus temp1. The next one is code generation. The final phase of the compiler is the generation of target code consisting normally of relocatable machine code or assembly code. Memory locations are selected for each of the variables used by the program. Move f id3, r2, mul f hash 60.0 r2, move f id2, r1, add f r2, r1, move f r1, id1. The first and second operands of each instruction specify source and destination respectively. Here the f in each instruction tells us that instruction deals with floating point numbers. Then next here we are get the 6 phases of a compiler for the given example. This is the final output for the phases of the compiler. Symbol table management. The symbol table is a data structure containing a record for each variable name which fields for the attributes of the name. The data structure should be designated to allow the compiler to find the record for each name quickly and to store or retrieve data from that record quickly. Thank you.